Hello YouTube. Today we're going to be doing some more MATLAB problems, just some practice problems that kind of get you familiar with using the system. So here we got a band gap dependency on temperature. Go through, read the problem, but I'm just gonna kind of walk through on how to do it. Just kind of some good practice for MATLAB because I know it's kind of like you fiddle with it on your own, but I want to make some videos that have some actual problems that you can work with. So I'm just gonna kind of go through the code here. I'm just going to write down the given information, which is e.g., I guess, initial, I'll call it, which was 1.170. And those units, I'm going to put it in the comments, were electron volts, which is EV. And then we have our alpha, which was 4.733 times 10 to the negative fourth power. And those units were in electron volts over kilogram or Kelvin, sorry, not kilograms. And our beta was 636. And those units are Kelvin. And our temperature. Now what we're going to do is we're going to use linspace to create, because it asked for 1,001 points, and linspace will create those 1,001 points. So we'll go 0, and then range from 0 to 600, right? So you put 0 to 600, and you want 1,001 points. So then you put another comma, and you put 1,001, how many points you want. So from 0 to 600, and then how many points you want in between. That's kind of how you use linspace, and that's going to be in Kelvin. And so I'm just going to call this EG1, and I'm going to write the given equation here, which is EG initial, which is the this part right here. So I'm just writing this in like MATLAB form. EG initial, pay attention to syntax here, minus alpha dot, because of this, just in case you always use dot for dot multiplication, or multiplying numbers in general. I just like putting the dots there just to be safe, but sometimes you don't need them. It's mostly used for like matrices and things, but anyway, then that divided by temperature plus beta, and that represents this equation right here. And now if you want to display the graph, right, because it's asked to graph, well, you have to make a figure. So you say figure 1, and now the figure will be displayed there. Now what do we want to plot? Well, we want to plot temperature versus that initial graph there, which I made as EG1, which is this right here. And what's really cool, you can actually title the plot, which is awesome. So just type in title, and what you want to title it, put EG versus T for silicon. And we can label the axes too. It would be X label, not X titles. Common mistake, X label. And temperature in Kelvin. And then we can have Y label, and that would be EUG, which was electron volts. And then what's really cool, if you want to put like a little key, kind of like a, to show what you want to, what's on your graph, you can put legend here, and then put your standard to show what the line represents, like a key code. So you put standard E versus T. And then we'll have new temperature. New temp equals 300, and that would be in Kelvin. Then we could put our EG2, because we're going to now want to show when the temperature is at 300K. So I'm just going to call it EG2, which was EG initial. So I'm just going to write all this down here. But we're going to want the new temperature in there. So I'm going to copy this and paste it here. Remember, we're calling this 2, and we want the temperature to be new now, right? So using the new temperature, just pop that in there. And that's pretty much how we can define it there. And we can print what we want to show. So when temperature is 300K, EG has a value of whatever you want to show it there. So percent off, new line, 9 EG2. And oops, I forgot to close that thing. Boom. And then you run your program. Cool. And boom, there it is. So that's what Legend does here. It puts this little key box there, and thought that'd be a cool problem to go through, and then we'll do part B. Just gonna separate this here. Problem 1B. And now it's saying we want to just use the values of the temperature above 300 Kelvin and use this following relation here. So since we have a different range of which part of the graph it wants, I'm just going to call it the new temperature range, and let's call it, I don't know, let's call it R temp, so the range here. And that would be the values from 300 to 600, and we're going to want a lot of points, right? So I'm going to do linspace from 300 to 600, and we want, let's do 1,001 points in between. So that's above 300, right? And then we went up to 600. So for those values of those points, in those points, let's type in that equation again. So I'm just going to copy and paste it, and I'm going to call it EGR for the R temp. And instead of it being new temp, we're just going to change it to R temp, because that's the values we want in the equation now. And yeah, so that's that. And let's make another figure here. We'll call it figure 2. And we'll plot R temp for the x-axis and EGR for the y-axis. And we'll title it EG versus T for silicon, X label, temperature in Kelvin, Y label would be EG, which is in electron volts. And to plot both the graphs on the same figure, why don't we're gonna need, because the part B asks us to compare the graphs, so we're gonna put them on the same graph. So what we want to do is do what's called hold on, and then I'll make sure that line that stays there, and we're gonna overlay another graph on the same plot. So now I'm gonna call this one, I guess, EG3, because now we got to compare it to this little equation they gave us here, which is given. I'm just gonna type it out: 1.025 minus 2.8 times 10 to the -4th, times that R temp, which is that range of temperature that it wants for us. I'm just gonna do this here, kind of keep that separate just so it's clear. It's always easy to put more parentheses to make it more clear to the computer. R temp, we're going to plot those now, EG3, title it EG versus T for silicon. And now what we're going to do is put a little key, so it's going to be two lines on the same graph. So this key will be legend here. We'll have standard EG versus T, and that was the first one, right, that we did above. And now we're going to do the second one, which was EG versus T from 300 Kelvin to 600 Kelvin. And then we'll do a hold on. And grab the power sign there. Boom. There we go. Whoop. And there are the graphs. And there's our little key that we made. Cool. We did it. All right. Great job.